Let's look at another example. Determine the measure of angle CBE in the figure. In the given figure, arc AB is the intercepted arc of both inscribed angles ADB and ACB. Thus, angle ACB also measures 32 degrees. So, in triangle BEC, we already know the measures of its two angles, BEC and BCE. To solve for its third angle, which is angle CBE, we can use the theorem the sum of the interior angles of a triangle is 180 degrees. That is, measure of angle CBE plus 85 degrees plus 32 degrees is equal to 180 degrees. We obtain 63 degrees. Other theorems involving parts of a circle are the following. An angle inscribed in a semicircle is always a right angle. Why do you think the inscribed angle is a right angle? Well, if we have a semicircle, its central angle is equal to 180 degrees. And according to the inscribed angle theorem, the inscribed angle will have a measure of 90 degrees, which is a right angle. Here's another theorem. The opposite angles of a cyclic quadrilateral are supplementary. Quadrilateral ABCD is called a cyclic quadrilateral. That is, all its vertices are on the circumference of the circle. According to the cyclic quadrilateral theorem, measure of angle A plus measure of angle C is equal to 180 degrees. Similarly, the sum of the measures of angles B and D is 180 degrees. Intersecting chords theorem. The measure of an angle formed by two chords that intersect in the interior of a circle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. In the figure, the measure of angle 1 is equal to 1/2 the sum of the measure of arcs AC and BD. Let's have some examples. Solve for x and y in the figure. ABCD is a cyclic quadrilateral. Therefore, angle ADC and angle ABC are supplementary. So 70 degrees plus y is equal to 180 degrees. And so we're able to solve for y, which is equal to 110 degrees. Inscribed angle ADC, and central angle AOC intercept the same arc AC. Thus, x is equal to 2 times 70 degrees, which is equal to 140 degrees. Example 4. In the given figure, measure of arc AC is equal to 110 degrees. Measure of arc AD is 30 degrees and AB is a diameter. Find x. Arc AB is a semicircle. Thus, 110 degrees plus measure of arc BC is equal to 180 degrees. From this equation, we can solve for the measure of arc BC, which is equal to 70 degrees. According to the intersecting chords theorem, x therefore is equal to 1/2 times the measure of arc BC plus the measure of arc AD. Substituting the values, x is equal to 1/2 times 70 degrees plus 30 degrees is equal to 50 degrees. Let us now define the lines associated to a circle. A tangent line is a line that intersects the circle at exactly one point. A secant line is a line that intersects the circle at exactly 2 points. Here are some theorems about tangent and secant lines. A tangent line is perpendicular to the radius of the circle at the point of tangency. Another theorem is the measure of the angle formed by two tangent lines intersecting in the exterior of the circle is equal to 1/2 the difference of the intercepted arcs. In the figure, measure of angle ABC is equal to 1/2 times measure of arc ADC minus measure of arc AC. The same applies if the angle is formed by two secant lines or a secant line and a tangent line intersecting in the exterior of the circle. In the figure, lines AS and AP are secant lines. Measure of angle A is equal to 1/2 measure of arc PS minus measure of arc KN. In the second figure, line EF is a tangent line and line HB is a secant line. Measure of angle EFH is equal to 1/2 the measure of arc HE minus measure of arc BE. Let's have some examples. In the given figure, lines RD and BD are secant lines intersecting at D. Measure of arc RDB is equal to 5x minus 10. Measure of arc EC is equal to 60 degrees and arc RB is equal to 13x plus 7. Find the measure of arc RB. Applying the theorem, we have the equation 5x minus 10 is equal to 1/2 times 13x plus 7 minus 60 degrees. Multiplying both sides of the equation by 2, we have 10x minus 20 is equal to 13x plus 7 minus 60 or 13x minus 53. Combining like terms, we have negative 3x is equal to negative 33, and dividing both sides by negative 3, we have x is equal to 11. To solve for measure of arc RB, we substitute x equals 11 in the expression 13x plus 7. Thus, we have 13 times 11 plus 7 is equal to 150 degrees. Let's have another example. Solve for P and Q in the figure. In the figure, angle BOC is a central angle with measure equal to P. Thus, its intercepted arc, arc BC, is also equal to P. Measure of arc BAC is equal to 360 degrees minus P. Segments BD and CD are tangent to the circle and intersecting at D. Applying the theorem, 1/2 times the measure of arc BAC minus the measure of arc BC is equal to 40 degrees. That is, 1/2 times 360 degrees minus P is equal to 40 degrees. Solving for P, we have P is equal to 140 degrees. Consequently, since angle BAC is an inscribed angle, Q is equal to 1/2 of P. That is, Q is equal to 1/2 of 140 degrees, which is equal to 70 degrees. Now it's your turn to practice.